can't go back to me. I can't go back to me. Expected out of you when a norm's not a choice for you. Tell me now, what the fuck do you do? I fly away. I know I gotta
without flinching when it explodes behind them. There's no way. I call bullshit on that. I need an MRI. I've got soft tissue damage. There's no way I don't have soft tissue damage.
You know I don't speak Spanish. In English, please. Huh? You pooped in the refrigerator.
everyone. We're just going to get started in a couple of minutes, so grab a seat. Hi, everyone. Thanks for coming tonight to Rangle. We're super excited to be hosting one of our very own, Jordon McKoy. He's a software developer, and he's going to be leading the talk tonight. Enjoy.
Thank you. So everyone, thank you all for coming out tonight. Just want to make sure everybody in the back can hear me okay. Perfect. If at any point you can't, just yell at me to speak louder, and we'll go from there. So as introduce me, I'm a software developer here at Rangle, and about a month ago, I wrote a blog post on GraphQL Yoga, just taking a brief look at how to set up a GraphQL server. Very eye-opening, and while I was writing that, I was taking a look at the Apollo server that it's built on top of, and I looked at the Apollo client as well, and that's what really gave birth to this idea for this talk. So tonight I'm very excited to talk to you about GraphQL. For those of you that are familiar with it, there's a lot of implications for client-side developers as well as back-end developers, and no matter what part of the stack they work on. And tonight we're going to go and talk about that. So this title here is a little bit misleading. Redux, a state management library, cannot be replaced straight up by GraphQL, a query language for your API. So that's one thing I just want to get out of the way right now. I feel like a lot of people are ready to jump on me for that. That being said, Apollo client does offer some features that allow us to treat its cache the same way we would treat a Redux store. And this opens up a lot of possibilities for front-end developers. So you don't need Apollo client to use GraphQL or any other GraphQL server out the gate, but the client does bring some out-of-the-box features that might be a little bit cumbersome to set up and implement yourself. So before we dive in, I just want to take a quick poll. How many of you have used Redux in a React application before? The majority of the room. So how many people have used GraphQL in a React application before? Well, actually a lot more than I thought. So if you had the ability to choose GraphQL but decided not to, anybody have any reasons why they decided not to use it? No, okay. What if you had, Sorry? Security is definitely something that you have to be conscious of when implementing GraphQL, for sure. Now, when I talk to some front-end developers, some of the concerns that they had with implementing GraphQL is they don't work on the back end. They think of GraphQL as a server-side technology. Why should I have to care about it? Or there's no time to refactor. They love GraphQL and what it can offer you, but they're already months into a project. The timeline isn't there. The budget isn't there. Maybe on the next project. Well, I hope tonight that we can address some of those concerns and show you ways to work around that and still be able to leverage GraphQL for your applications. So, we have a bit of a lesson plan tonight. We're going to start with a review of Redux. Then we're going to do a quick review of GraphQL, make sure everyone's familiar with it. Then we're going to take a look at the Apollo client and what it offers you as a React developer, followed by some code examples to tie everything together. Now, there's some learning outcomes I'd like us all to have at the end of tonight, to be able to answer questions like, what is GraphQL and why should I care about it? How can GraphQL help me build better applications? And of course, can I replace Redux in my React applications with GraphQL and the Apollo client? So let's start with the definition of Redux. And this is just taken from the official Redux website. Redux is a predictable state container for JavaScript applications. Helps you write applications that behave consistently, run in different environments, and are easy to test. Now, I want to highlight these things because I feel like they're key attributes to Redux. And if we're going to be looking at something that's either going to be replacing Redux or reducing its role that plays in our applications, it should be able to uphold these values as well. So in Redux, it's a simple way that data flows in one direction. We start with our components. We dispatch an action picked up by reducers that update the state, push that to the store, and then change the props for any components that are subscribed to it. So what problems does Redux solve for us? First one I'd like to highlight is knowing what part of state change in our applications. So in, let's say, a fairly sized application, if you try keeping your state in a single object and many parts of your application can make changes to that, it'd be very easy for there to be inconsistent state. It'd be very hard to debug. You can almost think of it as trying to detangle Christmas lights when you take them out every year. And also subscribing to state changes. One of the things that Redux does really well, it makes it clean to subscribe and then get notified and update parts of the application that need new state. And a bonus feature I like with Redux is able to pass values from the top of your tree down to nested components. Now again, you don't need Redux for that. You can use the React Context API, but Redux just makes it very easy to do that. So what's so great about Redux? One, it's predictable. When you dispatch an action, you know which reducer is going to fire. You know the change it's going to make to your state. And that predictability is one of the reasons I think people love Redux so much. You're not going to be surprised as often as you would without it. It's a single source of truth. Makes it a little bit easier to find where you have inconsistencies and bugs in your code. It's quite easy to test. Again, actions, reducers, they're just plain JavaScript objects. And you can just make assertions against those. If you have side effects, you can handle those in a library like Redux Stunk or observables or sagas and not have those intertwined with the rest of your code. That's part of the great ecosystem around it, as well with the Redux dev tools. So what's not so great about Redux? Well, for one, it's up to you to make sure you're not mutating your state and you're actually keeping it consistent. Can anybody offer any suggestions of what's also not so great about Redux, what you don't like? Sorry? Sorry. Okay. Too much code, yes, absolutely. So a little bit of riddle here. Boilerplates. There's a lot of process involved with Redux, whether it's your action files, your action types, your reducer file, then if you're using something like selectors or sagas, there's just a lot that goes into it. And on top of your component, That's a lot of context switching, and it's very context heavy. But again, this time trade-off, managing all those different files, is what grants us that predictability that we come to love about Redux. So now that we wrapped up the review of Redux, we're going to move into looking at GraphQL. So GraphQL is developed by Facebook, just like React, and it's defined as a query language for your API and a server-side runtime for executing queries using a type system that you define. So query language, just a specification for procedures of information retrieval and sometimes modification. And I want to highlight again this is server-side runtime because a lot of people have this thought that GraphQL just lives on the server. I don't need to interact with it as a client-side developer. But again, we're going to show that it's much more than that. So GraphQL starts with the schema. And this is just an example pulled from a schema, for example, a restaurant application where you define a custom type. In this example, it's an order, and you have a meal. And again, you can just think of it as a model for your data. So I like to use a restaurant analogy when explaining how GraphQL works with your React applications. You start with your client. You can think of it as a customer at this restaurant. They sit down. Your client wants to know which data can I order or which data can I request. And with that, you have your schema. And your schema is essentially a menu that will tell your client, hey, this is what you can request. And then when they make that order, it's handled by the server, which is just a chef that serves your data. And in GraphQL, the server would use your resolvers as a recipe to make that dish. So in essence, making a query is like ordering food. I think you can tell I was a little hungry when I made this slide. So this is just an example query here. We're going to pass in an ID to a specific meal. We're going to request its name, its origin, and the price. We're going to send that back to our chef, and the chef is going to make us some jerk chicken for $12.99. Pretty good deal, I think. And again, you can notice that the shape of this data, it's JSON. So again, it's very familiar to work with, easy to work with. Now, if we want to make a change, we use a mutation. So we're able to pass in an ID as a variable and pass in the price that we're going to be changing. And then we're going to request that we get the ID and the new price back as a result. So now we're going to update that to $9.99 if they're having a special that week. So this is just an example of GraphQL architecture for application. You have your client, you have your GraphQL server, and your GraphQL server is what connects all those different data sources together, whether it's a SQL database, your Express server, a third-party API, it doesn't matter. You can connect it and pull it all through the GraphQL server. So your client only has one endpoint to worry about. Now what this means, what it can encourage, is to move any data transformation logic from the client to the server. So as a client developer, you no longer have to worry about, how am I going to store this data? How am I going to paginate it? That's all handled by the server. And the way I like to think about it is, again, your client's the customer, not the chef. The client should never be in the kitchen with the chef. So what problems does GraphQL solve for us? Well, since it's an alternative to REST, a lot of its solutions are to REST problems. One of them being multiple client round trips. It's not uncommon in a REST API to have to make 3 separate calls just to get enough information to build the data that your view needs. With GraphQL, you define in one query exactly what you need to build your view, and that's handled by GraphQL. Also, bloated REST responses. I feel sometimes when requesting data from REST, it's like asking somebody where they got their shirt and getting their life story as a response. It's just too much information. But again, you request exactly what you want, and you get no more, no less. And these are big wins for mobile clients as well, where you're trying to keep your network calls as small as possible and as few as possible. So what's so great about it? It's declarative. Just like query language or React itself, you specify what you want, and it figures out the rest. It's self-documenting. So with the schema, you get a full surface area of your API. And if you're onboarding a developer on your team, you can tell them to take a look at the schema. They can look at what data is available, how it relates to each other. And with tools like the graphical REPL-like interface that comes with the introspection, they're able to go in there and actually test out queries and mutations against your backend. And they can copy those directly from there into your client environment, and those will work just the same way. Also, nested queries, one of my favorite features. So again, with REST, you'll often have to make 3 different calls to get your data, but because you're only dealing with one endpoint, GraphQL server is going to sort out where that data is coming from and build it together, no matter how it's nested. It works across the stack, so there's multiple client libraries, whether you're using React or a different framework, and your server doesn't have to be written in Node. You can use something like Ruby as well. And one of the best practices around GraphQL is not versioning your API. They believe in the continuous evolution of your schema. So with REST, whereas a client, you have less control over how the data is returned. As a server developer, making even a small change can end up breaking changes for clients. You don't know how they're using that. But with GraphQL, you can make a change by adding a new type, adding a new field, and because clients are only requesting exactly what they need, they're not going to be requesting that new data that could possibly cause a conflict. So what's not so great about GraphQL? It's not a silver bullet, and like Redux, give you overkill for your project in some scenarios. One of the things that's not so great is the schema and the resolver definition. You have to have your schema laid out before, you have to have those resolvers laid out before, otherwise GraphQL is not going to know how to find that data that you're setting up. So again, it's a little bit of process there, and it's not faster than REST. Most cases, you are only making one round trip call, but those 3 calls that you would have been making on the client side, they haven't disappeared, they've just been moved, and now you add an additional round trip. So there are ways to optimize that and get performance gains, but when I started using GraphQL, I thought, oh wow, I'm only making 1 call, it's so much faster, but that's not the case. So now we're going to dive into the Apollo platform, and there's 3 foundational libraries in their ecosystem of GraphQL tools. So the first is the client, which we'll be spending time tonight looking into, and that's there for data binding. There is the Apollo gateway, or the Apollo engine, which again is just a gateway that adds some features like an additional cache layer. There's performance and error tracking, and that sits between the client and the server. And the server is your GraphQL runtime, so it facilitates the connection of multiple data sources, as we saw. So why use Apollo? Again, it works with any GraphQL server, so you can have the Apollo client, but have your GraphQL server written in anything you'd like. But again, you get the data binding, and out of the box, you get caching and pagination built in. You don't have to write logic to handle that, as well as you get options like for refetching data, retrying requests, and polling out of the box. It's incrementally adoptable. So for teams that are worried about refactoring and having a big time investment, you can install it and try it out on just one component. See how it works, if it matches your workflow, and then as you go along, refactor component by component. So while I was doing some research in the cache, I came across this great joke I had to share. So Martin Fowler's blog, I'll let you read this one. So there's been multiple variations of this joke. And I feel as someone you might share Philip's sentiment there. Okay, so let's take a look at the Apollo cache and how it fits into the Apollo client lifecycle here. So you have your bound UI component. It'll dispatch or make a GraphQL query, and then the Apollo client will process that query, request the data from the server sends down the result, and automatically that response is going to be normalized and cached, stored for you, and then your UI component is going to be updated. So very similar to how the Redux data flow was. So Apollo client does come with its own dev tools, and this is an image here of the dev tools. You can see we're looking into the cache, and on the right-hand side, you're going to see that there's an array of messages that were returned. And all those messages were then broken out into their own individual objects and assigned an ID and a type name as well in a flattened data structure. So looking at the cache, we kind of get an idea of how Apollo stores data, but how can we leverage this now to store our data that we would like to put in there? And the answer is with Apollo links. So Apollo link is a pluggable network layer, modular components for GraphQL networking. You can think of it like middleware for Apollo client. And you can compose them as a chain. As you can see here, there's already a host of links for error handling, for managing context, batching requests, handling WebSockets. But the two I'd like to focus on tonight are the Apollo link state and Apollo link rest. So Apollo link rest allows us to make REST calls inside of a GraphQL query. So what this means is you don't need a GraphQL server in order to query a REST endpoint. And that data is automatically managed by Apollo client. So you get that caching and the normalization of a REST endpoint without having to go through a GraphQL server. And again, it's great for prototyping. So if you're just trying to test out Apollo client, see how it might work on your team, but you don't want to make the full investment, you can use this to query your existing REST endpoints and see how that works. That being said, if you're trying to do something a little bit more complex, because it is limited in nature, you might want to move that into a server. So next one is link state, and this is what allows us to manage state through the local cache. So it works by just exposing some read and write functions to the cache, and allows us to combine local and remote data. So in the example before, when we took a look at a query for the restaurant, if we wanted to add another field that's, say, for the rating the dish, but we didn't want to send that information to the server, we want that to live just client side, and then maybe we're going to persist it, we can actually add it into the same query, and then using something called a directive, we can specify and tell GraphQL, hey, we're not going to send this to the server, we're just going to keep it local. So now if we look at our updated data flow, we have a REST and local cache that we can query the same way we would query the server. And this is great because it offers that same consistency. We're not having to do anything drastically different in order to get that functionality. So this is very powerful, but it does create a potential problem. We now have our Apollo cache and our Redux store living side by side. Now again, this isn't necessarily an issue, but it does require a delegation of responsibilities, and it's something we have to be concerned about. We also lose that single source of truth that we enjoy from Redux. So, once more, I just want to reiterate, we're not comparing Redux and GraphQL, the two very different things. What we're looking at is the potential to use the Apollo client cache as a data store versus Redux. That being said, Redux and Apollo client, you can see there have some similarities. In Redux, we dispatch an action. In Apollo client, we are making a query or mutation. In Redux, again, you have your reducers and your store update, where in Apollo client, it's handled by the normalization and updating the cache. So again, Redux has a store, Apollo client has a cache. So now we have the information, and we want to go ahead with that. Where do we manage the state now? So there's a great blog post by James K. Nelson in which James specifies or identifies 5 different types of state that we have in our Redux applications. So there's data. This is just response data from external API calls. There's communication state, and this would be the status indicators we're talking about. Is this call fetching? Is it loaded? Is there an error? That'd be communication state. There's control state. So it'd be anything for forms or UI state, toggling an accordion, for example. Session state, so user data, user token, what's their username or their permission, and location, localization data. So example, preferred language. Now, I know some teams prefer to Redux all the things. It's perfectly acceptable. That's an acceptable approach. You can, again, handle all these things in the Apollo client, in the cache. That being said, Apollo client really excels with data fetching. So things like the data state and communication state, moving that into the Apollo client, you definitely get the benefits of having the normalization, and the communication status, as we're going to see shortly, is handled by Apollo as well. Now your control session location state, that's where you want to sit down with your team and talk about where are we going to handle this and move from there. So before we look at the code examples, I just wanted to introduce the components that we actually use in the Apollo client library in React. So in the latest version of Apollo client, they have a query component. The way it works is you pass it a GraphQL query, and it'll fetch the data for you declaratively, and then when it's returned, it's passed down to the component that you're wrapping through a render prop API. And along with this data, you also get a loading and error prop as well. To make changes, the mutation component works in much the same way. You get your loading prop, you get your error prop, you get the data, but it also passes down a function that you use to trigger when you want this mutation to take place as a result of some user interaction. So because we're wrapping individual components now, it really encourages you to have single purpose components. Much the way in the functional program paradigm, you have single purpose functions, and provide some interesting ways to compose your components moving forward. Personally, I found this to be a little challenging at first. I was used to having a Redux component where you pass it a bunch of functions and a number of props that weren't really related, but you use them to compose your views anyways. With the Apollo client, to achieve that same thing, you're nesting multiple levels deep and passing all those down, and it gets a little bit like prop drilling. So there's a bit of a trade-off there. But if you don't prefer to nest your components, you can do something like composing your functions if you've used recompose or use the compose function from Redux, it's a similar concept. So just to review now, we've talked about Redux, talked about GraphQL, as well as the Apollo client. We've looked at what is GraphQL, a query language for your API. Why should I care about it? Well, it's an alternative to REST. There's some advantages there, such as the nested queries and shaving your payload size. And then how can GraphQL help me build applications? So moving logic from client side that handles data transformation, moving it to your server, allows your client side team to move faster. They can focus on building user experiences and not managing data. As well as your server side, you can move all that to one spot, and then you're not having to rewrite that on every different client. And again, the single purpose component paradigm, if that's something that appeals to you, you also get that as well. So now we're going to look at some code examples. So this is just a Redux initialization here, setting up our store. Or set up our action type. So this is for our restaurant example here. We set up our actions. We have a reducer that handles that data request, manages the different states. We use something like selectors. We have the API for the REST endpoint. If we're using something like Redux Saga to make that request. And then we finally get to the component in which we import all of that. on mount, we're going to make the request, and then map over the result. So already you're looking at 5-6 files just to make one request. Where when you compare that to GraphQL, we initialize it, initialize our client. And one thing I like to point out is here we're defining our cache from this Apollo library, but this can be any cache. There's a lot of open source caches you can use, or again, you can re-implement your own using something like Redux as well. Here we set up our links, which is just an array. We have middleware for handling errors, managing state. We're setting up a custom REST endpoint, and then this HTTP link is for our for our GraphQL server, and you can pass in options like a header if it requires authorization as well. So this is the data fetch. There's a co-location here of the queries with the components. I personally like this as you don't have to manage multiple files. You can just have it here, same side of the query, because that component's going to know what data it needs. And this is it. So you pass it the query, we're going to pass it the variable, and then syntax here there. We get our data, we can map over that, but we also get the loading and error props, and we can control the state of the component using that. Now to test that component, we'd export the component that we're wrapping, as well as the Apollo client query separately. Or sorry, the component and the query separately. We import both of those. And we're going to have to mock the Apollo client. We don't want to make calls using the real backend during tests. So we import the mock provider. We wrap that. And then we can just check if it's containing the loading error. Or if we're testing the final state, we pass the result to the mock. We use async await to wait for a tick to happen. That data is loaded, and then we can check that as well. So now if we want to fetch from a REST endpoint, we're using the same or similar query here. Using the REST directive, we tell what endpoint we are using that we've set up in our Apollo client. We give it the REST endpoint path. You can pass in a variable if needed. And then again, we're requesting the name of the meal and the price. And then in our query, we get that data and we can map over it. Now you can see in this example, I've wrapped that in a mutation component just to show that we can also call a REST endpoint to delete. We're going to accept no response. And then the first prop is that function that we can use there. So that was just a brief look at the code examples. I'm going to have more in my GitHub link. I'll be posting later next week as well, if you'd like to take a look at that. So finally, we arrive at this last question. Can I replace Redux in my apps with Apollo Client and GraphQL? Yes and no. If you're just looking at replacing your data fetching layer, absolutely, I think GraphQL is a great target for that. However, there's other states that while you can write them directly into the cache and retrieve them, they might not be as smooth as the implementations that you currently have in Redux. And of course, there's other factors that attribute to that, like what's your team like? Do they understand GraphQL? If not, it might not be the perfect time to ramp them up. There's timelines to consider, and even cost considerations as well. Because if you're looking to move a lot of the data fetching logic from the client to the server, your server costs are undoubtedly going to go up. So that's something to keep in mind as well. But I definitely think it's a great alternative and something people should explore. So that concludes the talk. Thank you very much for listening, and we'll start the Q&A session. I had one in the back there. Absolutely. Yep. Yes, there is a way to handle file uploads with GraphQL and Apollo client. Sorry? That I can handle file uploads? I think it's depending on how you're going to handle it, but I don't see why it'd be bad, negative or positive either way. It just depends on your intention and what you have available to you.
You tried using GraphQL with TypeScript? And if so, was it used recently or not?
I have not used it with TypeScript. So the nice thing about GraphQL is it is typed, the data itself. Now, the Apollo client in the next version is supposed to be code generation that will convert JS to TypeScript and it's supposed to play nicely together. So I haven't had a chance to do it personally, but I know there's options out there for it. So, and Flow as well.
Any other questions? I'll come over to you.
Just to reply to the question about TypeScript, you can use interface for the types. So inside GraphQL, there are types that define the payload, right? So you just define the interface for it, and the compiler will not have errors.
Hey, do you have separate routes for dealing with authentication, or do you have that as mutations?
So the authentication you can set up as mutations. With GraphQL, you just want one endpoint. That being said, there are libraries that you can use on your server. Set that up, pick up if you need separate permissions, or you have a different token. So again, that'd be more of a server-side concern than the client.
Yeah, that's what I meant.
Yeah.
Apollo client provides in-memory caching that it's very basic, and you mentioned there are third-party libraries that you can use as a caching solution. So I want to hear your experience about these libraries because we are struggling with in-memory caching.
So the different caching options, personally I've only used the in-memory cache, which if I recall correctly is a map over the values. There is Hermes, which is developed by the Apollo team as well, and that's a graph over the values, so it's supposed to offer some different performance advantages to the memory cache. And then again, there's other custom caches that you can build. But personally, I've only used the in-memory cache.
Any other
Yeah.
questions?
Sorry, I was just going to mention the question around authentication. Like what we did was we used COA to address certain REST endpoints for both file uploads and for authentication, and then exposing a GraphQL endpoint for our queries for the front end. So, and that actually we found worked pretty well and let us kind of divorce concerns. So that was it.
One more here.
Any opinions on Apollo versus I think Relay's the other client library? Any insights or opinions on that debate?
I haven't looked at Relay recently. I know as of a couple years ago, Relay wasn't that incrementally adoptable. So just based on that, I preferred Apollo client. But as things have moved on, I think the functionality is starting to parity. Personally, I just prefer the Apollo stack. I think they have a lot of great features. They have a great team working on it. So.
Any other questions? Okay. I'll leave it to you.
All right. Thank you very much.